We'll come to Space Explorer 2024 for more videos. Subscribe our channel. Ever wondered how satellites stay up in space without falling? It's a fascinating question that has puzzled many of us. After all, with gravity constantly pulling everything down to Earth, how do these man-made objects manage to stay afloat in the vast expanse of space? It's a question that has intrigued scientists and stargazers for centuries. From the early astronomers who first charted the stars to modern-day scientists who send probes to the far reaches of our solar system, the quest to understand how objects can defy gravity has been a driving force in the field of space exploration. You might think it's magic, but it's actually simple science. The principles that keep satellites in orbit are rooted in the fundamental laws of physics. By understanding these laws, we can unlock the secrets of how satellites maintain their delicate balance in space. Satellites don't just hover, they're in a constant dance with gravity. This dance is a delicate balance between the satellite's forward momentum and the gravitational pull of the Earth. It's a bit like a cosmic ballet, where each satellite follows a precise path to stay in orbit. It's like a game of cosmic tag where they're always falling but never losing. The satellite's speed is just right to ensure that as it falls towards Earth, it keeps missing it, thus staying in orbit. This continuous freefall creates the sensation of weightlessness experienced by objects and astronauts aboard the satellite. This delicate balance is what keeps them from plummeting back to Earth or hurtling off into the vastness of space. The precise calculations and adjustments made by scientists and engineers ensure that satellites remain in their designated orbits, performing their vital functions without interruption. So buckle up, space cadets, as we explore the fascinating world of orbital mechanics and uncover the secrets behind these technological marvels. From the initial launch to the intricate maneuvers that keep them in place, every aspect of a satellite's journey is a testament to human ingenuity and the power of science. Get ready to have your minds blown wide open. The universe is full of wonders, and the story of how satellites defy gravity is just one of the many incredible tales waiting to be discovered. Before we dive into the world of satellites, let's talk about gravity. We all know gravity as the force that keeps our feet firmly planted on the ground. It's what makes apples fall from trees and keeps our planet in orbit around the sun. Sir Isaac Newton, a super smart scientist, figured this out a long time ago. He discovered that every object in the universe attracts every other object with a force proportional to their masses. The bigger the object, the stronger its gravitational pull. That's why we're stuck to the Earth. It's a whole lot bigger than an apple. So, if gravity is constantly pulling things down, how do satellites stay up? The answer is speed. Satellites travel at incredibly high speeds, thousands of miles per hour. This speed is crucial because it allows them to counteract the pull of gravity. Think of it like this: imagine throwing a ball horizontally. The harder you throw it, the farther it travels before hitting the ground, right? Now imagine throwing it so hard that it circles the entire Earth before landing back in your hand. That's essentially what satellites do, but on a much grander scale. Sputnik's legacy, a giant leap for satellite technology. Speaking of grand scales, let's take a trip back in time to 1957 when the Soviet Union launched Sputnik 1. This little satellite, about the size of a beach ball, became the first artificial object to orbit Earth. It was a pivotal moment in history, marking the beginning of the space age and igniting a fierce competition between the Soviet Union and the United States. Sputnik showed us that it was possible to put man-made objects into orbit, opening up a whole new world of possibilities for communication, navigation, and scientific exploration. A ball on a string visualizing orbital motion. To better understand how satellites stay in orbit, imagine a ball tied to a string. This simple analogy can help us grasp the complex forces at play in orbital mechanics. If you swing the ball around in a circle, the string acts like gravity, pulling the ball inwards. This inward force is crucial for maintaining the circular motion. But the ball's forward motion, or velocity, wants to keep it moving in a straight line. This is due to inertia, a property of matter that resists changes in motion. These two forces, the inward pull of the string and the outward force of the ball's motion, are constantly balanced. This dynamic equilibrium is what keeps the ball in its circular path. This balance is what keeps the ball moving in a circle. Without this balance, the ball would either fly off in a straight line or be pulled directly inward. It's the same principle with satellites. They are in a constant tug-of-war between their forward velocity and the gravitational pull of the Earth. Gravity is the string, the satellite is the ball, and Earth is the center of the circle. This delicate balance allows satellites to orbit our planet, providing us with vital services like communication, weather forecasting, and GPS navigation. Satellites, the silent guardians of our modern world. Today, thousands of satellites orbit our planet, silently performing tasks that have become essential to our modern lives. These silent guardians are the backbone of our global communication network, ensuring that we stay connected no matter where we are on Earth. They beam TV signals to our homes, allowing us to stay informed and entertained with a vast array of channels and programs from around the world. Provide us with GPS navigation, guiding us through unfamiliar territories and helping us reach our destinations with ease. They also monitor weather patterns, giving us crucial information to prepare for natural events, and help us explore the vastness of space. These satellites send back invaluable data, expanding our understanding of the universe and our place within it. From tracking hurricanes to predicting earthquakes, satellites provide early warnings that can save countless lives and reduce the impact of natural disasters. Satellites play a crucial role in keeping us safe and connected. They facilitate communication in remote areas, aid in disaster management, and support emergency response teams during crises. They are a testament to human ingenuity and our insatiable curiosity about the universe around us. Engineers and scientists work tirelessly to design, build, and deploy these sophisticated machines, pushing the boundaries of technology and innovation. So the next time you look up at the night sky, remember that those tiny points of light are not just stars, but also the satellites that make our modern world possible. Take a moment to appreciate these technological marvels that have become an integral part of our lives. They are the silent guardians, tirelessly working to ensure our safety, connectivity, and understanding of the cosmos.